Okay, so I think we are live now.
Yeah, everything is working fine. Akshay sir, you can start.
Okay, sir. Thank you. Okay, so good afternoon, everyone. And we are going to start a new chapter that is work, energy, and power. This is again a very important chapter you have completed. I hope you have completed Newton's laws of motion. So we will start from work, energy, and power. And okay, so first of all, okay, first of all, we will define work. Work, basically in physics, when we are talking work, we are talking about mechanical work, not a normal work that we encounter in our daily life. We are talking about mechanical work. So what is work? Work is basically a method to transfer energy. Listen carefully. Work is basically a method to transfer energy. When we are talking about mechanical work, then it is a method of transferring mechanical energy. And mechanical energy is, I think, say, it is a method to transfer mechanical energy. And mechanical energy is what? Kinetic energy or potential energy. So make a thing in your mind. Make a thing in your mind that is, whenever a work is done, either of the two or both of them will change. Are you getting my point? So this is the basic definition of work. And what we define in mathematics term is work is said to be done on a body if a displacement is created in the body by the force. And this is a simple term. Again, if I say that a body is placed here, it has a mass m and is placed here. And if I apply a force on it, some force F on it at an angle theta from the horizontal, then, and I say again, after some time, this block is shifted to this place and this displacement is d. Then what work is in mathematical term or in formula term? The work is force dot displacement. This is the mathematical term. Work is force dot displacement. Now, this force dot displacement can be written in many ways. Like you can say F d cos theta. So if I talk about what is F cos theta here, F cos theta is the component of force in the direction of displacement. Component of force in the direction of displacement. So if I say, if you need to calculate the work done, either do a dot product of force and displacement, or you can say, work is force parallel to the displacement into displacement. This is another form that we mostly use. That work is force parallel to the displacement into the displacement. The clear picture is work is force dot displacement. You can either choose dot product or you can choose force parallel component force into the displacement. So these are the things that we are going to discuss, not going in a deep detail about these. These are basic things. So let's move further. Okay, one more thing that I need to discuss here. If on a body, there are multiple forces. Suppose a body M is placed here and there are multiple forces like F1, like there is a force F2 and many other forces are there. Then if you are asked to calculate the total work done, then total work done is the scalar sum or algebraic sum of all the individual works. If there are many forces, then each force will do a work and you can calculate total work done by calculating the individual work done. This is the simple term. Vector or scalar, two things are there. So work is a scalar quantity and can be added algebraically. Another thing. Unit, if I talk about, is joule. These are simple things. Okay. So there are two more situations than that we encounter in our daily life while calculating work. I will do it later. Okay. Chali. Let's start with a question. Question says, a block of mass M is placed here and a force of 20 Newton is applied on it and another force of 10 Newton is applied on it. Two forces are there. 10 Newton is horizontal, 20 Newton is at an angle 60 degree from the horizontal. And the block displaces by 2 meter. You need to calculate the work done. You need to calculate the work done. Take 1 minute of time and answer. Okay. Anyone got the answer? Okay. Let's start. So there are two forces acting on the block and displacement is given. So what I told you, total work done is the algebraic sum of individual work done. So you need to calculate 10 Newton work done and 20 Newton work done. One way is to solve like that. Another way is to solve, calculate the resultant force and then solve. So I will tell you both the ways how you calculate, which one you like, you can adopt. Okay, 40 joule, someone is saying. Okay, let me check. Okay. Okay. So 10 Newton force is there. What I told you, the force should be in the direction of parallel to the displacement. Block is displaced in the horizontal direction. This 10 Newton is in the horizontal direction. So this 20 Newton should also be in the horizontal direction. No? So we will take a component of 20 Newton. And if I take a component of 20 Newton, this is the block of mass M. If I take a component, this component will be 20 cos 60, which is again 10 Newton. Cos 60 is what? 1 by 2. So total force parallel to the displacement is F total या F parallel जो होगा हमारा, that F parallel will be 10 plus 10, that is 20 Newton. So work done will be this F parallel dot displacement. And F parallel is what? 20 Newton. Displacement is what? 2 meter. So it is 40 joule. And he got the right answer. Very good. I think it's clear to you. Or you can solve it individually by calculating W is equals to W1 plus W2. W1 is the work done by 10 Newton. This force, like this is F1, this is F2. If you solve it like that, then W1 is equals to F, displacement is 2 and cos 0, plus W2 is F is 20 Newton, displacement is 2 meter and cos 60. Cos 60 is what? 1 by 2. 2 cancel. 20 and 20 again 40 joule. This is another way. So you can pick your way, and I will give you another 1 minute for the next question. Try solving it. Here the question is calculate, I think calculate work done by F1 and by F2, and third part is total work done. Take your time. Okay. Anybody is answering? Okay, someone has answered. F1 is 40 joule. Okay. Work done by F1 is, again, I think it's not the question to be solved actually. Work done by F1 is force is 20 Newton, displacement is 2 meter, and angle is 0, that is 40 joule. If I talk about work done by F2, work done by F2 is 20 joule. Okay. Total work done is 20 joule. Okay. So let's check it. Work done by F2 is, you can again solve it by various methods. You know, F2 is 20 Newton. Displacement is in the horizontal direction, like this way. And force is this one. The angle between them, if I say this angle is 120°, then work done is force displacement cos 120. What is force? 20. Displacement is 2. And what is cos 120? That is minus 20 joule. Total work done is W1 plus W2, that is 20 joule. If you were not asked about individual work done, you were directly asked about the total work done, then what you could do, what you could have done is, if I need to calculate the work done directly, then I will take the component parallel to the displacement. If I take the component parallel to the displacement, this F2 is 20, parallel to the displacement will be 10. F cos theta. F cos theta will be 10. So total work done will be 20 minus 10. F net, yeah, F parallel total work done would be F parallel dot displacement. F parallel will be 20 Newton is right, 10 Newton is left. So net F parallel is 10, displacement is 2, that is 20 Joule. Okay, you can reply me whether it's too quick, too slow, or what kind of things you are feeling, and so that I can proceed along with that. Okay, is everything all right till now? Just reply once. Okay, I hope. So what I have told you, work done is the method to transfer energy. That's the first thing. Mechanical work done I am talking about. So mechanical energy is transferred whenever work is done, either it's kinetic energy or potential energy. Then work done is W equals to F dot ds or F dot d. These two things we have learned. Net work done is calculated by algebraic sum. Now moving further. This is a simple question. A particle moving in the XY plane, just solve it. And after that, we will move towards variable forces. Okay. Force is given. Displacement is given. And work done is force dot displacement. I think you can clearly solve it. 5I plus 2J dot displacement is 2I plus 3J. Dot product you can easily solve. I is multiplied with I, that is 10, plus J is multiplied with J, that is 6, that is 16 Joule. That is another basic question. Now we are moving further and increasing our level. I hope till now everything is clear. Now moving further. Another some basic things are there. One is zero work done. We have learned that work done is F d cos theta. Theta is the angle between force and displacement. So what is zero work done? Zero work done will be when this theta is 90. When theta is 90. When theta is 90, work done will be zero. There are some situations you will encounter. Like if I say that this block is moving horizontally, calculate work done by gravity. So gravity is acting downwards. Displacement is horizontal. So work done will be zero. If I ask you work done by the normal, in this particular question, normal will be this one, and work done by normal will be again zero. Again, if I ask you a simple pendulum is revolving, is just oscillating. The work done by the tension, will be what I say, tension is like that, and displacement, if I complete it, it will be a complete circular path. Displacement is always perpendicular to the tension. Then work done by tension is also zero. Okay. I will put it to yellow. Done. I think yellow is visible. Okay, similarly, positive work done is whenever theta is 0 to 90, not exactly 90, up to 90. That is called positive work done. Similarly, another situation is negative work done. I am moving faster in these sort of types because these are the known things for us. After that, we will move further with a good type of questions. Negative work done is when theta is greater than 90. Whenever theta is greater than 90, work done is negative. So what is the physical meaning of positive work done and negative work done? Can anyone answer? What is the physical meaning of positive and negative work done? If a block is pulled by this force, then work done is positive because theta is less than 90. Then we can conclude that positive work done increases its kinetic energy. Positive work done increases its kinetic energy, or you can say positive work done can increase the mechanical energy of the system or try to increase the mechanical energy, while negative work done try to decrease the mechanical energy. This is the difference, fundamental difference between positive and negative work done. Negative work done you will encounter in the friction. In the case of friction, you will encounter negative work done. So what friction does? It tries to minimize, it tries to decrease the mechanical energy of the system. I am talking about mechanical energy of the system. It tries to decrease. So this is the basic difference between positive and negative work done. So now I hope these things are very pretty much clear already to you. Okay. So there is a question on your screen. Can anyone give it a try? Anyone? You have 1 minute of time to try it. Who is observing this motion? The observer is here. This is the observer who is observing this motion. Okay. Moving further. Have a look at that. First of all, we will need to draw a FVD of the same. If I draw, there is a weight mg. There is a normal reaction n. Okay. So there will be a friction F. And the component of mg will be like this. This is mg sine theta, and this one will be mg cos theta. This is the FVD. So what we need to do, find out the work done by the friction in time t if the block is at rest with respect to the inclined plane. Okay. What we need to calculate, work done by the friction. So first of all, if this block is at rest, what does it mean? That friction must be equal to mg sine theta. Forces must balance now. So if block is at rest, you have learned this in the Newton's laws of motion, then friction must be equals to mg sine theta. This is the one thing. Now we need to calculate work done is equals to force dot displacement into cos theta, angle, some angle between them. So first encounter, first check the angles. This angle is theta. Okay. And if I say we need to check, this is the displacement of the block. Truck is moving this direction, so this is the displacement. This is our friction. This is our friction. So we need to calculate this angle. We need to calculate this angle for the calculation of force dot displacement. Okay. This angle can be calculated as, this is the y-axis. This is our y-axis. This is our x-axis originally. Now y-axis got shifted by theta. This angle is theta. So this one is 90 minus theta. So what is our angle from F to direction of displacement? That is, theta is, here we can write, theta is 90 plus 90 minus theta, which is 180 minus theta. What I have written, work done is force dot displacement. Force is F, displacement is, we will calculate displacement, and angle between these two is 180 minus theta. Friction is mg sine theta. Displacement is in time t. Time t displacement will be, speed is v into t. Displacement is equals to v into t. And cos 180 minus theta is minus cos theta. This is work done by friction. This is again a very simple question, but what we need to do, we need to calculate the angles and need to understand that friction must be equals to the mg sine theta if block is to be at rest. Any doubts in that? Moving further. This is the same question as previously given. Calculate work done by gravity, work done by friction, and normal reaction on block in time t. Again, they are asking you, there is a lift and elevator which has an inclined plane and a block of mass m is placed on that. The lift is moving upward with a velocity v and block remains at rest. We need to calculate the work done by the gravity, by the friction and normal reaction. Okay. Take your time. Again, we need to draw the FEDs. This is what mg. This is what normal reaction. There will be a friction F, component of mg sine theta, and again there is a component mg cos theta. These are the forces acting on the block. Again, block is at rest. What does it mean? That friction is balancing the downward gravitational pull. Mg sin theta is balanced by friction. If that is the case, then again we can write friction is mg sin theta. Now, what we need to calculate? We need to calculate work done by gravity. Okay. First part is work done by gravity. Okay, let's check. This system, the lift is going upward with the velocity v. In time t, this block will move by how much distance? If seen by this person, this block will move by a distance vt in the upward direction, and gravity is mg in the downward direction. If these two forces I take, these two forces are opposite in sense. Gravity is downward, displacement is upward. Then work done is gravity is mg, displacement is vt, and angle is 180. Are you getting my point? Why this angle is 180? Because 180 mg is downward force and the displacement is upward. So this will become minus mg vt. This is work done by gravity. Again, moving further, this is work done by gravity. Now work done by friction force. Friction force. Friction force is what? Friction force is this one. Again, we need to calculate the angles. If I say, where is the displacement? The displacement is this Vt. This is the displacement. And friction is this one. So angle between them is this. And this angle is theta. So what is the angle between friction and displacement? I hope you can see that the angle between force, friction force and displacement is 90 minus theta. So we can calculate work done by friction is friction into displacement is Vt into cos 90 minus theta. Friction is what? Mg sin theta Vt, and cos 90 minus theta is again sin theta. So it will become mg sin square theta Vt. This is work done by friction. Another thing. These are the two things. And now we were asked about normal reaction, work done by normal reaction. What we need to do? In any such situation, we need to find the angle between force and displacement. So force is n, displacement is vt, the angle is theta. How can I say that angle is theta? This is simple geometry. This one is theta, this one is also theta, vertically opposite angles. So there are many ways to calculate these angles. I am saying that vertically opposite. So this is theta again. So you can clearly solve it by work done by normal force, normal reaction into displacement into cos theta. Now you need to calculate the normal reaction. Normal reaction is what? N, block is at rest, so N is equals to mg cos theta. Mg cos theta, displacement is Vt, and this is again cos theta. So it will become mg cos square theta Vt. Is it clear to you? Now moving further, I hope we will move towards work done by variable force. This is the most important thing that we are going to discuss. This is your homework. Do it as a homework. This is very simple question. You can do it as a homework. Okay, moving further. Work done by variable force. This is the most important thing that you need to use very frequently. From now, just be prepared about the real physics. You will be able to understand these things if you have learned previous past simple cases. Now we will discuss about work done by variable. What is variable force we mean? Force may be varied by two things. Like I can say, force may be varied according to the displacement. Like for example, number one case is with position force may vary. Another thing, it may vary with time. Like as time passes, the force decreases, or as time passes, the force increases. Like you started pulling something. Initially, you are more energetic. You are pulling it with more energy. But after some time, your energy decreases, and your pulling decreases. Okay. You can take the screenshot as well for the homework question. Okay. So now, work done by variable forces. Forces may vary with position, may vary with time. If you encounter a spring, if I tell you about the spring, like this is a spring. If I start compressing this spring, initially it is very easy to compress the spring. Initially, it can easily be compressed, but as I compress it further, it becomes very difficult for me to compress it. That means the force exerted by spring is increasing with the displacement I have produced in it. So these are the two situations that we will encounter. That force is varying with position or with time. In both the situation, what is going to be the concept of it? We will discuss it. So first take it by step. So first we will take the variable forces that is varying with position. And I will take a simple case. Simple case is what? That force is varying in the x direction only. That means force is along the x direction and changing in the x direction gradually. Or you can say linearly. It can be x square, it can be x cube, it can be root x, whatever it may be, but the concept will be same. So just imagine one thing. This is the basic thing that we are going to discuss. Like a block is here, and force acting on it is F is equals to AX. AX represents that as distance x increases, as the block moves further, the force on it increases. So let's discuss that we need to displace it from point A to point B. This is the displacement that we need to done, and we need to calculate the work done during this displacement. So in that situation, what is the standard procedure? It says take a small displacement in its path. Take a small displacement in its path, which is dx. And why we choose a small displacement? Because during that small displacement, this is very small displacement dx, which is known as finitely small displacement dx. In that displacement, the force may be assumed constant. The force may be assumed constant. So we can calculate the work done in this portion. So work done during small displacement, छोटा सा वर्क डन, स्मॉल वर्क डन, dw is equals to f dot dx. This is the small work done during this small displacement. Can I say I can choose various small displacement in it, like another small displacement, another small displacement? Infinite number of small displacement can be taken in between these 2 points A and B. So total work done will be what? In sum of individual work done, like this is W1, this is W2, W3, W4. The sum of all these work done will be the our total work done. So these sum of total work done is written as integration f dot dx. From where to where? We need to calculate it from A to B. This is what we call work done by variable force. A and B could be positions. So we will put the limit under that, and f dot dx. So this is the work done by variable force when force is varying along one direction, that is only x. There may be situations when force may be varying in more than one direction, like force is varying in x as well as y as well as z direction. In that situation, a more general form is used, and I will say that most general form is work done by variable force is integration. If force is varying in all the direction, then I can say force in the x direction has a component I cap, plus force in the y direction has a component j cap, plus force in the z direction fz k cap. This is the force dot displacement. So what is displacement? Small displacement dx in the x direction, dy in the y direction, and dz in the z direction. This is going to be the most general form in case of variable work done. Forces by variable work done. This is going to be the most general form. Again, I am repeating one thing, that fx is what? Force component in the x direction, fy force component in the y direction. Similarly, dx is the x component in x component of displacement, y component of displacement, and z component of displacement. Okay, we will make it more clear by the giving simple example. Let's talk about that. Okay, you have an example on your screen. And you can answer it. Okay. What are they talking? They are okay. Let me clear one thing. These are the questions that are usually asked in the mains examination. When force is variable, it can be formed in many different ways. This same question, like I have formed it in different way, like this. Question is same, but pattern is slightly changed. We can solve it in time. This is time varying. So we will do it. So now let's do it. F is given, displacement is given from this point to this point, like this is point A and this is point B. What I have told you, that work done is equals to, okay, let me ask you one thing, whether it's varying in only one direction or in two directions. The force is varying in the x direction as well and in the y direction as well. So we will use the most general term, that is integration fx I cap plus fy j cap plus fz k cap dot displacement is dx I cap plus dy j cap plus dz k cap. X component is, that is 4x I cap, y is 3y j cap, z is 0. So we will not put that. And this is dx I cap plus dy j cap. So it can be written as 4x dx. I multiplied with I, dot product. 4x dx plus 3y dy. This is the, some people remember not the this result, they remember this result as well. How it can be written as in general, w is equals to fx dx plus fy dy plus fz dz. You can remember any of the two, either this most general term or simplified term, whatever. This is going to be integrated about x, about y. So in terms of x, the limit is particle moves from 0 to 3, 0 to 3. And in the y direction, it is moving from 0 to 2, 0 to 2. After putting the limits, I will solve it. 4 integration of x is x square by 2, limit is 0 to 3 plus 3 integration of is y square by 2, limit is again 0 to 2. After solving, this is 2. Okay, this is after limit, we put the limit 3 square is 9 into 2, 18 plus here we put 4. Y square will become 4 divided by 2, it's 2, 2, 3 is 6. So that is 24 joule. Is there anyone who got the right answer? It's 24 joule. Is it clear to you? Okay, I will give you one more question, similar question to you in the form of example. Like answer is also mentioned 24 joule. Okay. So I will do one more question. Time is allowing me to solve that question as well. You can try, give it a try so that you have a chance to recall whatever you have learned. So here we have given force as x I cap plus y j cap and asking us to calculate work done by this force. This time they have not given us the coordinates of the point. They have given us the position vector of the coordinates. They have given us the position vector of the coordinates, and they asked us to solve the work done. Okay, we will focus on our most general term. W is equals to, okay, W is equals to, what is the most general term? Integration fx I cap plus fy j cap. I am not writing k cap because it is not mentioned here. K is not given. It's not in 3 dimensions. Dot dx is dx I cap plus dy j cap. This is the most general term, most general form. So W is equals to, again we will write fx dx plus fy dy. In terms of x, if you notice that these positions are given with respect to a frame, and according to that frame, x is 3. And according to that final position is x equals to 5. So we can write 3 to 5. And here we can write 8. This is 8 to minus 4. What is the change in the coordinate? 8 to minus 4. This is our limit. So f in the x direction, x component of force is mentioned here as x, and y component is mentioned here as y. So it will become 3 to 5 x dx plus 8 to minus 4 y dy. This is again a very simple term to integrate. X square by 2, 3 to 5, plus y square by 2, 8 to minus 4. So you can easily solve this integration by just putting this limit. That will be 5 square 25 minus 9. That is 16. If I am not wrong, 5 square 25 minus 9, that is 16, divided by 2, that is 8. Plus, if I put y equals to minus 4, that will be 16 minus 64. 16 minus 64 is minus 64, minus 48. One by 2. If I put minus 4, that will be 16 minus lower limit is 64. That is 8 plus 1 by 2. 16 minus 64 is what? Minus 48. That is 24. So it will become 32 of Joule. I hope it's very clear to you. I think that's the time. I hope you all are getting the questions and nothing is wrong with you. You are able to solve few of questions, few of them at least. So on a okay, yeah, definitely it's a minus. It's a minus term. Very good. Minus 16 Joule. Very good. There is a minus 24 Joule. Very good. So I hope we can turn it off and we'll continue from here in the next class. Till then, bye.